Hi, today we discuss the LeetCode problem number 9, palindrome number. Given an integer x, return true if x is a palindrome integer. Here's a definition of the palindrome integer. An integer is a palindrome when it reads the same backward as forward. For example, 1 to 1. If you read forward, it's 1 to 1. And if you read backward, it's still 1 to 1. So the output for the example number 1 is true. In the example number 2, we have a negative number in the input. The output is false is because after it's written backward, the number will become this. The negative sign is on the right side. It's not a proper number, so the answer for the example number 2 is false. In the example number 3, the input is a multiple of tens. After you reverse this integer, 10 will become 0, 1. 0, 1 does not equal to 10, so the answer for the example number 3 is false. From this example, we can conclude that any number is a multiple of 10 cannot be a palindrome. And the last, we have a constraint here. The input for our problem is in the range of -2 to the 31st power to the 2 to the 31st power minus 1. This is equivalent to the minimum integer and the maximum number in the Java. Let's analyze this problem with an example. For example, we have an input 1 to 1. First, we want to reverse this number and save the reversed number into a variable. We call this variable reversed. In the input, the least significant digit is at 1's place. Here we have tens and hundreds. The process to reverse the input is as such. First, we'll pop out the least significant digit from the input, and then add this least significant digit into the reversed. So the pseudocode for this step is pop the 1's digit from the input, and the formula for this step is input mod 10. And the second step is to append this digit into the reversed. And the formula for this step is reversed equal to reversed times 10 plus pop. And the third step, we need to shift the rest of the digit to the right. So this step is to truncate the ones digit from input and shift to the right. The formula for this step is we will update input with input divide by 10. Let's continue the demonstration. This time, we will keep track of the values for all the variables. The initial value for pop is 0, and the initial value for reverse is 0. The initial value for input is 1, 2, 3. As we did for the first digit here. The pop equal to the input mod 10. It equals to 1. And the reversed equal to reverse times 10 plus pop equal to 1. So the reversed after the first movement is 1. And the input will be updated to, here is 1 to 1. 1 to 1 divided by 10 equals 12. So these are the values for the current state. Now we continue the process to move this digit from input to the reversed. First, we'll calculate the pop. It's equal to input mod 10. The input is 12. So it's 12 mod 10 equals to 2. So here is the pop. We get the 2 from ones digit. And then we calculate the reversed is equal to the reversed times 10 plus pop. The current value for the reversed is 1 times 10 plus 2. It equals to 12. So we will append 2 after 1. We move the 1 to the 10th digit and append 2 to the 1st digit in the reversed. Then we update the input. Current value for the input is 12. Divide by 10. It equals to 1. So we move 1 to the 1st digit in the input. Now it comes to the last iteration to move the 1 from the input to the reversed. First we calculate the pop equal to input is 1 mod 10. It gives you 1. Reversed equal to the current value of a reversed which is 12 times 10 plus the value of pop is 1 equals to 121. So we shift these 2 digits to the left. The pop equal to 1. Now after calculate the reversed equals to 121, we append the last digit to the reversed. Now the reversed equals to 121. After move 1 from input to reversed, we update the input. It equals to the current value of the input, 1 divided by 10 equals to 0. So there's no more digit in the input and the value for the input is 0. Our process to reverse the input stops here. After this process, we will compare if reversed equals to the input. If it's true, then we will return true. Else, return false. Of course, all these steps are in the while loop. The condition for the while loop is while input greater than 0. Then we come back to our demonstration above. The value for the reversed is 121. The initial value for the input is also 121. So the reversed number equals to the input. This is the example number 1. It will return true. This is the pseudocode based on the example number 1. Does it work for the example number 2? If the input is a negative number, does our pseudocode still work? Yes, it still works. It's because when the input is negative number, it will fail at the condition in the while loop. So the whole process will never be executed for the negative number. And when it comes to compare the reversed and the input, the value for the input is negative 121 and the reversed remains as 0. Is because the steps in the while loop will not be processed for the negative number. In this case, for the negative number, it will always return false. Our pseudocode can also work for the example number 3. But of course, we can add a condition to check for the multiple of 10s before the while loop, so it will save some running time. To check if the input is a multiple of 10, if it's true, we will return false. There is one more detail I want to discuss. Do we need to deal with the overflow? If the input is big enough, for example, our input is the max value, then the reverse will be overflow. If you implement the solution with the Java, you don't have to deal with this situation. It's because if the number is overflow, then the Java will return a negative number. Let's go to the LeetCode playground to test this out. Here's the LeetCode playground. I have prepared the test case to test out the integer overflow. I initialize the reverse with a value which is bigger than the max value. Then I will print out the max value for the Java integer and the value which is overflow. As you can see, our reversed is max value plus 10. When we print out the reversed, the Java will assign a negative value to the reversed. So if we compare the reversed with the input, they will not be equal. Then our solution will return false. As said, in case of overflow, negative number is returned. So our solution will always return false. Okay, this is all we need to discuss for the solution number 1. Next, we will go to the LeetCode website to do the implementation. Here's the code I have prepared in the LeetCode website. Before we will reverse the input, we declared 3 variables. The first is the integer variable called reversed. This is the variable to save the reversed value of input x. The second variable is the integer variable temp. It's a copy of the input value because we don't want to change the initial value from the input. We will use the initial value of the input later on to make decision if the input is the palindrome. So for the whole process, we will change the value of the temp. The third variable is the integer variable pop. Here we have a while loop to reverse the input digit by digit. The while loop will continue as long as the value of temp greater than 0. Once temp reaches to 0, the process will stop. The first step in the process is to pop the 1st digit from the input. The formula is pop equal to temp mod 10. The second step of the while loop is to append the pop to the reversed. And the formula is reversed equals to reversed times 10 plus pop. The third step is to shift the input to the right. The formula is temp equals to temp divided by 10. After all the digits from the input are reversed, we compare the reversed value with the initial value from the input. If these two values are equal, then it will return true, which means the input x is a palindrome. Let's test the implementation. So in our first test, the input is 1 to 1 and the output is true, which is the correct answer. We can also test the negative number. So for the negative number, our implementation returns false. We can also change the test case to the example number 3. Our solution returns false. Okay, let's submit the solution. The submission was successful. The runtime is 11 milliseconds and is faster than 81% of all the online submissions. Our solution has a runtime (11 milliseconds) and is faster than 81% of all the online submissions. Now, let's discuss the second solution, which has a better performance than our solution number 1. Let's analyze the solution number 2 with an example. For example, we have an integer 1, 2, 3, 3, 2, 1. Our process will reverse this number and save this number to the variable reversed. First, we will move the digit 1 from input to the reversed. After this step, we can see that the reversed is still smaller than the input. Then our process continues. We move 2. After this step, the value of reversed is still smaller than the input. Then we move the digit 3. After we move the 3, we can observe that the value of reversed equals to the remaining value of the input. At this point, we can conclude that the input is a palindrome integer. We don't have to continue the process to move the remaining digits from input to reversed anymore. So in this scenario, if we observe that reversed is no more smaller than input, then we can stop the process. If the value of reversed equals to the value of input, we can return true. Let's have another example. This time, our input is 1, 2, 3, 4, 3, 2, 1. Initially, the reversed is smaller than the input. We start our process by moving the first digit from input to the reversed, then the next. At this point, the reversed is still smaller than the input. Then we continue the process. After moving the digit 3, we can see that 1, 2, 3 in the reversed equals to the 1, 2, 3 in the input. In the input has one extra digit, 4. Because the input has odd number of digits, so the 4 is in the middle. The input 1, 2, 3, 4, 3, 2, 1 is a palindrome with a 4 in the middle. But our process doesn't know it should stop here. So it will continue to move the 4 from input to the reversed. After we move the 4 from input to the reversed, now the reversed is no more smaller than the input. The reversed now is greater than the input. Our process will stop here. After the process stopped, the reversed is 1, 2, 3, 4, and the remaining number in the input is 1, 2, 3. We can't just compare the reversed with the input. In this scenario, we will compare if the input equals to reversed divided by 10. This formula will give you 1, 2, 3. And the input is 1, 2, 3. So this integer is a palindrome. So we already analyzed the solution 2 with 2 scenarios. The first scenario is 1, 2, 2, 1. And after we move half of the digit from the input to the reversed, we can conclude that this integer is a palindrome. And in the second scenario, after we moved this part of the number from input to the reversed, then we can conclude that this integer is a palindrome. Now let's go back to our original implementation and let's see how to modify implementation to make it work for the solution number 2. The stopping condition for the while loop is no more input greater than 0. We'll change the 0 to the reversed. If input is greater than the reversed, we will continue this process. And the steps in the while loop remain the same. After we exit from the while loop, we will check if reversed equals to the input or reversed divided by 10 equals to input. So these are the only changes we need to make to create the algorithm for the solution number 2. The solution number 2 doesn't process every digit in the input. It only processes half number of the digits in the input. For example, here. Our process in the solution number 2 will stop after this point. Next, we'll go to the LeetCode website to modify the existing implementation for the solution number 2. So here is the implementation we have created for the solution 1 in the LeetCode website. We're going to modify on top of this implementation for the solution number 2. First, we don't need this temp variable anymore because we don't need to preserve the initial value for the input. So we can take this out. And here we change the temp to the X. And here we change all the temp to X. And in the stopping condition for the while loop, we don't compare the X with 0. We will compare X with reversed. If X is greater than reversed, the process continues. And for all the steps in the while loop will remain the same. Once we exit from the while loop, we will check if reversed equals to X or the reversed divided by 10 equals to X. Okay, let's test our code. In our first test case, the input is 10, and the expected output is false, but our implementation returns true. It's because we haven't dealt with the numbers, which is the multiple of 10. Now let's come back to discuss the numbers which are multiples of 10. For example, we have number 1, 2, 2, 1, 0. Here's our input, and here is the reversed. In our solution number 2, we'll move 0, 1, and 2 to the reversed. After we move the digit 2, the value in the reversed is 1, 2, and the remaining value in the input is also 1, 2. So without dealing with the numbers which are multiple of 10, our solution will return true. But actually, 1, 2, 2, 1, 0 is not a palindrome. So we have to add one more condition in our solution to deal with the multiples of 10. Before enter the while loop, we will check if the input is the multiple of 10. So we will add one more check before the while loop. We will check if the input mod 10 equals to 0. If equal to 0, then we know that it's a multiple of 10. But we also need to be careful here. If the input is 0 itself, it's a palindrome. But the 0 divided by 10 also equals to 0. So we have to exclude the 0 from our check. So here we will check if input mod by 10 equals to 0 and input is not 0. If this condition is true, we will return false. Now let's go back to the LeetCode to add this check for the multiples of 10. Before the while loop, we'll have an if statement. X mod 10 equals to 0 and x does not equal to 0. If this condition is true, then the input is a multiple of 10, then we will return false. Let's run the code again. This time, the output is the same as expected, false, with the input 10. Let's change the test case. The input is 0. We have the correct answer true. We change the test case to 1, 2, 1. The answer is true. We change to 1, 2, 2, 1. It's also true. Let's try with negative number. The answer is false. Seems our implementation works. Let's submit the code. The submission was successful, and with our solution number 2, which only process half number of the digits from the input, we have the runtime 6 milliseconds, and is faster than 99% of all the online submissions. So our solution is slightly better than solution number 1. The runtime for our solution number 2 is 6 milliseconds and is faster than 99% of all the online submissions. And the time complexity for the solution number 1 is log 10 n. So n is our input, and for example, our input is 1, 2, 2, 1. If we take log 10 for this number, we will get a value smaller than 4 and greater than 3. And in fact, when we process this number in the solution 1, our process iterates 4 times to process each digit. So that's why the time complexity is log 10 n. And in the solution number 2, because we only process half number of the digits, the time complexity will be log 10 n divided by 2. Okay, this is all we need to discuss for the LeetCode problem number 9, palindrome number. Our discussion ends here. Thank you for watching.